ఈరోజు మన డిస్కషన్ ఏంటంటే డైఎలక్ట్రిక్ కాన్స్టెంట్ ఆర్ రిలేటివ్ ఎలక్ట్రికల్ పర్మిటివిటీ ఆర్ రిలేటివ్ పర్మిటివిటీ. So how these value can help us to understand in electrostatics. Okay, let us see that. First of all, if you want to understand this, you have to know the formula. So what is this electrostatics force? F equals to 1 by 4 pi epsilon naught into q1 q2 by r square, where r is the distance between the two charges. So if you think about the force and this constant value epsilon naught, that is nothing but electrical permittivity in vacuum. If the two charges are placed in vacuum, what is the force, what is going to be the magnitude of force, that depends on this permittivity also. The similarly, that same two charges placed in a vacuum, so in a medium, so what is going to be that? F equals to 1 by 4 pi epsilon m, means permittivity in the medium, into charge, product of charge q1 q2 by r square, q1 q2 by r square. So if you want to know that what is this dielectric constant, sometimes it is going to be indicated with the k and sometimes it is epsilon r. So dielectric constant means with the k, relative permittivity epsilon r. This is nothing but the ratio of permittivities ratio. But what to what we have to understand? Permittivity of medium to permittivity of the vacuum, in vacuum. The same thing, we know that from here the force is inversely proportional to this permittivity value. If epsilon m is there, what you are going to get? This force is in case of vacuum, this force is in case of medium. If the two charges are q1 q2 are placed with the same distance in the vacuum or in the medium, so what is going to be their force ratio? That will be given by this dielectric constant or relative permittivity. So force is inversely proportional to permittivity అనేది మనకి ఈక్వేషన్ చూస్తేనే తెలుస్తుంది. సో ఎప్సిలాన్ ఎం ఉంది అంటే ఇక్కడ ఫోర్స్కి వాట్ యు ఆర్ గోయింగ్ టు సే ఎఫ్ నాట్ టు ఎఫ్ ఎం. So dielectric constant in two ratios you can say, one is permittivities ratio or force ratio. If you say that in terms of permittivity, medium permittivity to vacuum permittivity, or force in vacuum to force in medium, so these two ratio is known as what? Dielectric constant or electrical permittivity, relative electrical permittivity. So how this can give us the idea? The two forces when we are comparing, if the two charges are placed in vacuum and two charges placed in medium, that is going to be this value. So for example, relative permittivity of air, so and relative permittivity of air is relative permittivity that for which medium? Air we are taking. If you are taking that relative permittivity value, that one is 1.006, mean the force between the same charges in the at the same distances in vacuum as well as in the medium, what is their forces ratio? That is going to be given with this 1.006 approximately. If you take it as 1, that's why relative permittivity in the vacuum or air are approximately taken as a same, that is a 1, because 1.006, this point is then decimal 0.006 are negligible, you are going to say it as a 1 only. Next, if you take that relative permittivity value of glass, that relative permittivity for glass, if you take it, the dielectric constant or relative permittivity of glass, if you take it, it is going to be in between 3 to 4, or if I take that as average 3.5, what is the meaning of that? What is the meaning of that? The electrical property of that glass, if it is in case of vacuum and medium, that medium is here, it what? This glass, the force in the vacuum to force in the glass, here is the medium, that ratio is going to be what? It is 3.5. or what you can understand still more, if you compare F naught equals to 3.5 times of Fc. Okay, so force between the same two charges in the vacuum is going to be 3.5 times of the force which is in between the same charges when they are placed in glass. That idea you can understand. If it is the case of water, the relative permittivity or dielectric constant of water, that is going to be given as what? The value is 81. What you can understand? This F naught to F of water is equals to 81. Then again what you can understand? F naught equals to 81 times of the force in the water between the same two charges. Or if you say that in terms of electrical permittivities, what you can understand the same way, here what you can write? Permittivity in the medium is what? Here it is a water, to permittivity in a vacuum, that ratio is going to be 81. That means water permittivity equals to 81 times of permittivity in vacuum, 81 times of the permittivity in the vacuum. So like this, if you think about the dielectric constant, you can learn much about their forces ratio or their permittivity ratio. So this idea will be there. So